Hi everyone, today we're going to go ahead and learn about solving for exponents. And maybe you've done this yourself individually, maybe your teachers have somewhat introduced this, but this for the most part is a totally new topic, which wasn't covered in Algebra 1. And what we're going to do is we're going to talk about solving for exponents. Now let's talk about ways that you've solved already. So in the past, if I say 3x plus 2 is equal to 8, what's the whole point of us what's the whole point about this equation is we're just trying to solve for x. Solve for x. And in algebra, we learn all the different operations to solve for x. Like if I have a plus, I'm going to minus to both sides, the inverse operation, the opposite operation. And opposite or inverse operation of times 3 is divide by 3. So x is 2. And you probably could have guessed that. 3 times 2 plus 2 is equal to 8. Yep, that works. Yep, 2 is a righteous answer. X is 2. X has to be 2. There's only one option for 2. For x, it's 2. These problems got a little more difficult once we end up x squared plus 6x plus 8 is equal to 0. And now, there wasn't an easy way for us to solve it. We couldn't just minus 8. Because if I just subtract 8, you end up with x squared plus 6x equals to negative 8. And then now what? You still have two x's on one side. So we said, nope, we don't do that. Instead, we factor. We said instead we have x plus two numbers multiplied to become 6, but no, multiplied to become 8, but add up to become 6. 1, 8, 2, and 4. And we can see 2 times 4 is 8, but 2 plus 4 is 6. So we remembered that we would have to factor this. How would this go to 0? What x value would make this nicely go to 0? The numbers would be if x plus 2 is equal to 0 and the x plus 4 is equal. So what happens is we broke this up and it turns out this is kind of like we're back to easy street. Back to an easy idea of, hey, it's just an inverse operation, minus 2, x equals to negative 2, and minus 4, x is equal to negative 4. Okay. Now, just to verify this, to make sure you guys are believers here, if I say x is negative 2 squared and 6 times negative 2 plus 8, would this become 0? Is my guess of negative 2 actually going to give me 0? It doesn't look like 0, but 4 minus 12 plus 8 is negative 12 plus 12. Oh my goodness, that actually worked. So as the problems became more difficult, we learned new skills to deal with this new type of problem. And that's life, right? Every type of problem is going to be different, so we need different solutions. The way you talk to your mother and the way you talk to your father and the way you talk to your siblings, everyone has to be talked to differently, and that's how we deal with those situations, right? And for any job, every problem that you get has a different solution, and that's where experience comes in. The more experienced you are, the better you are able to handle these different situations that may come up. Okay, so let's do another one that we've been talking about recently. If I say the square root of x is equal to, let's say 3, what number could you square root to give you 3? You're probably telling me 9, but our inverse operation here is to square both sides. And when I square it, the squares cancel out. You can also write this as x to the 1/2 power squared. This becomes x to the 2 over 2, which becomes just x to the 1. Okay, so we're left with x to the 1 is equal to 9. Okay, so this is a method that we were just recently talking about when it comes to exponents. If I take the power of powers, we multiply them. And another way of looking at this is, okay, there are a lot of different ways of looking at this, unfortunately. It's a square root of x squared. Hey, I have a pair. That means we can take out the pair. That becomes x. Okay, x is 9. Great, yay. Okay. So what we're going to do now is we're going to look at a problem in which we're not able to solve for. And that's 3 to the x is equal to, let's say, 81. Now, look at the variable and where it's positioned. The variable is now in the exponent position, right? It's up on top. 3 to the blank power equals 81. Now we could just start guessing. 3 times 3 is 9. Okay, we're not there yet. Give me another 3. That's 27. Nope, not there yet. Give me another 3. That is 81. So how many 3's do we need? We needed 3 to the 4th power equals 81. Great, but we solved that straightly by guessing. It wasn't through an algebraic process using inverse operations. And we need a way to solve for exponents. Like, how do we solve how do we solve for exponents? And that is our big question today. And we will solve for exponents using not square roots, not radicals, but we will solve for exponents using logs, logarithms. And logarithms solve for exponents. Okay, and this is what we're doing today. Logarithms solve for exponents. Now, if you guys have a graphing calculator, sorry, not graphing, a scientific calculator with you, I'm going to show you our way here. So we have an identity that we're going to use to solve for logs, or use logs to solve for exponents. Here's the identity: a to the x equals to b. Okay, let's say we have some base to some exponent equals to b. And then we have an identity. Okay, this is the identity version. We say log base. Now let me reiterate the parts. This is the base, this is the exponent, and this is our answer. Okay, the base, exponent, answer. So we are going to rewrite this in this form using logs. Logs have a specific pattern that we're going to use here. So you write the word log, and then you first fill in the word which is the base, and then our answer, and this is equal to our exponent. Remember how we said logs solve for exponents? Well, I want you to notice that logs solve for exponents. Logs are equal to exponents. Logs are exponents. So whenever you log something, you are not looking at just some random value. You are only looking at exponents. Logs are exponents. So I want us to rewrite this. If I wrote 8, oh, not 8, I'm sorry. We use 3 to the x equals to 81. How would I write this in my log form? We write log. What is the base? Is 3x or 81 the base? The base is 3, so we write a little tiny 3 on the bottom. Okay, this is a subscript, very tiny 3. It's kind of like x squared. You know how we write x squared on top as a tiny 2? This is a base subscript, so it's like a tiny 3 on the bottom. Okay, and then we're going to write, next thing, we're not going to write 81. Sorry, we're not going to write x. We're going to write 81 is equal to log solve for what? Log solve for exponents. So this has to equal to my exponent here. Log solve for exponent. So we're going to come back to this in a little bit, but let's go ahead and give you guys some more to rewrite. If I write 5 to the x power is equal to 125. Now maybe you know that 5 times 5 is 25 times 5 is 125, right? 5 quarters is $1.25. So, but let's rewrite this. I want to show you guys how to get this on your calculator. Let's rewrite this as log. You always write the base. What's the base? What are we counting by? We're counting by 5s. So we write the 5 in little tiny subscript of 125 is equal to x, because logs always solve for exponents. And if you can get that in your head, that every time you see a log, this answer is an exponent, that's going to help you out. Because logs aren't regular numbers, they're all solving for exponents. That's an exponent. Whenever you see the word log, that's an exponent answer. Okay, let's do it one more time, and then I'll show you guys how to type this in your calculator. Let's do 10 to the x power equals to 1000. Okay, so how many times will I multiply 10 by itself? 10 times 10 times 10 times 10. How many times do you think I'm going to get to 1000? Okay, so to rewrite this, let's say log. What's the base in this case? Is it the 10, the x, or the 1000? Okay, and the base is the number that we're counting by. It's what you're telling log to count by. I'm counting by tens. Okay, what answer do I want to get to? 1000 is equal to x. All right, so from this step here, if you guys have a nice calculator where there's so many different scientific calculators now, I want to see what type of button do you guys have. So you guys can check out your scientific calculator right now. You can, if you're using an Apple one, where'd mine go? This is the one I use, okay, for my iPad right now. Oh, and there's always ads. As you can see in mine, I actually have a couple different logs here. I have log base 2, and I have something called log. And also in this little corner here, you'll see ln. That's actually also a log, but it has a base, what we call base e. So we're going to use, so that's my calculator. That's my cheap calculator. It's like 99 cents calculator. If you have a nice scientific calculator that looks like this, you see, if I see the log button and it looks like a box and a box, you have a more advanced calculator, okay? So if you have this version, you can type our answer. What is log base 3 of 81? You can type it as you see it. Okay, the 3 goes here and the 81 goes here, and go ahead and hit enter. But most of us do not have this nice calculator, and we have to write this in a way we can use on the calculator. So here's what we do. Here's our next rule before we go back and solve all of these. We have something called change of base. And we are going to change log base 3 of 81 into a log that I can use. If you can see here, I have log base 10 on the right, or a log base 2, or a natural log. These are the only ones I have on this cheap calculator here. If you see a log without any number, that's always going to be a number 10, and that's what we call a common log. But we don't need to worry about that right now. I just wanted to throw that out there, okay? So here's what you need to type on your calculator. For us to write this notation on my cheap calculator, you need to do something called change of base, which is rewriting this as a different log, as a log that we want. Log of 81 divided by log of 3. So a change of base means I can take my log and write it as 2 easier logs. And these easier logs we can now use on any calculator. So let's go and try this right now. On my calculator, I have to type in the number first. So here's the calculator. I'm going to type 81 log it divided by 3 log. Okay, that's what I'm going to type in my calculator. So I want you guys to try this on your calculator, whichever calculator you're using on your cell phone or a scientific calculator you had from last year. So I'm going to hit 81, hit the log. It doesn't matter which log you use, as long as you use the same log. Log divided by 3 log equals. And you'll see the answer you got is 4. 4. Is it true that we said this was 4 here? Is 3 times 3 times 3 times 3 81? Yep. Okay, let's try with this next problem. Log base 5 of 125. If you have a nice calculator, use it. If you don't, you have to do change of base. And this is something that we all have to learn, whether we have a nice calculator or not. Change of base. Okay, right here, log of 125 over log of 5. So try typing that on your calculator and see. Yes, you can use that log. Someone asked me, what if I have a calculator that just says log with nothing in it? This is an invisible 10. This is what we call common log again. And you can use that. Please use that. You can read log of 125 divided by log of 5 in this case. So if you have a calculator that's still kind of advanced, this is going to give you a parentheses. So you're going to write 125 in the parentheses, close the parentheses, divide by log 5. So you can type it as you see it. Advanced calculators are so cheap these days. They're like $10 and you get a lot of functionality of it. If we were in class, I would show you, but we do what we can. So please tell me if that worked out for you. If I take log 125 divided by log 5, what answer would you get? Let's go back up here. So hopefully you end up with, yeah, 3. Perfect. And see, we're solving for exponents now, something that we were not able to do before in Algebra 1 or geometry. So this is a new skill. What exponent would get me there? Okay, so make sure everyone, if you are trying this out, I hope you're trying this out. If you type log 81 divided by log 3, this is how I could type in my calculator, and that's going to give me 4. Because 3 to the 4th power is 81. If I type log base 5 of 125 or log 125 divided by log 5, I'm going to get 3 because the exponent of 5 to the 3rd power, that gives me 125. Yep, you have invisible 10. That's right. I love scientific calculators. Yes, they do a lot of the work for us. Now, let's look at this last one. If you see log base 10 of 100, let's do it the long way. Now, I want to show you something kind of interesting. As I told you guys, it doesn't matter which log you use as long as you stick to the same log. So this can be broken up into log of 1000 divided by log of 10. And try that. And see if you get the answer 3. Now, I want you to just try this. What is log of 1000? Do you also get 3? And the reason why you get 3 is because, like I mentioned before, there was an invisible 10 there. There's an invisible 10 there, just like this answer here. So a common log is an invisible 10 because we're counting by tens. Now this is important for us in math. It's because if you're trying to figure out about something called magnitude, how strong a number is, maybe you don't care about the actual number itself. You just care about how does that number compare to other numbers, and logs are helpful for that. It tells you how strong a number is in comparison to other numbers. Give me a sec, let me pause. All right, so let's try something else real quick. Since we're on this little topic here, I want you guys tried log 1000, right? And we said that was 3. You tried log of 1000 divided by log of 10. You said that was 3. Now I want you guys to try the other logs that you have. Look at the button, try to find the button ln here, okay? Natural log. Try this. If I write ln of 1000 divided by ln of 3. So not 3, I'm sorry, ln of 10. Do you still get 3? Some of you guys might have this natural log of 2. Log base 2 of 1000 over log base 2 of 10. Do you still get 3? And the idea is this change of base allows us to change the log into whatever we want, whatever our calculator will allow us to use. And hopefully you're seeing that it's no matter which one you use, as long as you use the same one, it'll give us 3. Okay, so that's one of our tricks. Now, why is this helpful to us? Is because all that questions that we could have done without a calculator, right? We could have done all these without a calculator. But what if I give you this? 3 to the x power is equal to 30. Can you think of 3 to a number that will give us 30? Not really, right? So let's make this up. If I say 3 squared, that equals to 9, okay? 3 cubed, that is 27. And 3 to the 4th, that is 81. So 3 to the x power is someplace in here. It's like 3 to what? What's the exponent? Is it 3 or 4? It's going to be x is 3 point something. And you guys hopefully can see that x is going to be someplace stuck between 3 and 4. We don't know what that number is. We could start guessing. You could say 3 on my calculator, 3xy, 3.1. Well, that's close, right? 30.1, but that's not right. So we can make it a little smaller. 3xy, 3.05. Okay? Oh, that's too small now. Oh man, let's keep trying. 3xy 3.08. Getting closer, right? Now, you can see that it's not going to be a whole number. It's going to be some type of decimal. And this decimal is going to be a irrational. It's never going to stop. Now, here we use, you can use natural log or common log whenever you're doing this. It's really up to you. So whatever you have on your calculator, as long as it's the same log over and over again. Okay. So here we go. Let's rewrite this using my identity. How could I write 3 to the x equals to 30 as a log? Remember the pattern. Log, solve for exponents. So don't log solve for exponents. So what part of 3 to the x is equal to 30 is my exponents? Log solve for exponents. So this better equal to x, my exponent. We always write a little number here in the corner. What's that little number called? It's called the base. 3x or 30. Which of these parts is the base? 3, right? 3 is the base. And our answer goes here. Now, I come up with a song which is kind of silly, so please don't make fun of me. But I call it the circle of logs. And this is what circle of logs means. 3 to the x power equals to 30. Circle of logs, 3 to the x power equals to 30. That's how I want you guys to see logs. It's always the base to the circle of logs, x power comes back to give you that result. We're looking for 30. 3 to what exponent is 30? That's how we want to look at these logs. Circle of logs. Sorry, sounds like a broken record. But I will sing that every time I write this. So I want us to now, seeing this as a log, type this in our calculator. Log of what? 30 divided by log of 3. So there's a lot of different ways, again, to type this in your calculator. If you have my cheap calculator, you type 30 log divided by 3 log. Okay, that's my cheap calculator. If you have a one step up calculator, you can type log, open parentheses 30, divided by log, open parentheses 3. Don't forget to close that. Okay, if you have the super cool calculators, you're just going to type log base 3 of 30 and hit equals. And you should end up with all the same answer. Let's go ahead and do this on my calculator here. If you guys do get the answer, can you guys type in the chat? Let's see if you guys got it. Give me at least 3 decimal places, if not 4. Okay. We're gonna do on my cheap calculator. I have to type 30 log. All right, I'm getting some good answers here. 30 log divided by 3 log equals, and 3.0959037. Does this number ever going to stop? No, it will never stop. It's not going to be a whole number for us. So we eventually have to just get kind of close. And let's use 3 decimal places. Now, if I say 3 to the 3.095, rounding up to 96, we round it up, right? So we're going to be a little bit above 30. So this is approximately 30. Let's try it. Practice with the calculator. 3xy, that's an exponent of 3.096. Yep, that's as close as we're going to get to 30. If we keep on going, 3xy, I'm just going to copy the whole exponent. I have all these decimals here, right? 3xy, 3.0959037. That's super close, right? 2.999999998. That's pretty darn close to 30. So we are now able to now solve for exponents. So that's the goal of our lesson. But let's go ahead and talk about what you guys are going to do. You guys are going to do the basic part of this, and you guys are just going to rewrite logs as our first thing. We're going to rewrite some logs. If I give you 6 squared equals to 36, please write this in log form. Okay, please write that in log form. How would I write this as a log? What's the base? What's the exponent? What's the answer? The base, the exponent, and the answer. So we always write the base in the corner here. That's 6. Log solve for exponents. Logs always solve for exponents. And the answer is here. You can double check to make sure you got this all in the right position. Circle of logs. 6 squared is 36. Yes, it is. So we want to be okay rewriting this using our identities for logs. It helps us see this a lot easier. Circle of logs. What if I give you something weird? 10 to the 0 power equals to 1. Let's write this as a log. Log, base, answer, exponent, right? These are the parts that we have to fill out. The base here is 10. What's the exponent? Exponent is 0. And our answer is 1. Is this true? 10 to the 0 power is 1. Now this leads us to one of the identities that we have for logs. If you take log, okay, of 1, it will always equal to 0. Why? Because anything to the 0 power is, what's anything to the 0 power? Let's give you guys some examples. Log base 3 of 1 is equal to 0. Log base 17 of 1 is equal to 0. Log base happy face of 1 is equal to 0. 3 to the 0 power is 1. 17 to the 0 power is 1. Happy face to the 0 power is 1. Circle of logs, circle of logs, circle, sorry. So we want to know this identity. Whenever you see log of 1, the answer is always equal to 0. Okay. Do we have any other weird logs like that? Actually, we do. If you ever take the log of itself, 3 to what exponent is itself? How do I get from 3 back to 3? 3 to the 1 power goes back to itself. So here's one thing we realize. If you ever take a log of a number, they cancel out and become just 1. Because isn't it true that log, so 5 to the 1 power is 5? Well, log 5 base 5, that's just 1. If I give you 3 times log of 4 to the 4th of 4 of 4, what happens to, what's this answer here? What exponent of 4 gives you back 4? That just becomes 1. Because this is equal to 1. Okay? So be able to say, hey, whenever you take a log with the same base, that is actually cancels out to just become 1. Now here's also a trick one. Can you take logs of negatives? If the base is positive, can I get a negative number? What exponent can make a positive 5 become a negative? And is that even possible? Can I say 5 times 5 times 5 times 5? Remember, exponents are just multiplying the same number over and over and over. Can 5 times 5 times 5 times 5 times 5 ever become negative? No solution. There is no way for us to log to become a negative number if our base is a positive number. Not possible. So this is not a possible solution. Sometimes when you're solving for logs, this is on the side. Sometimes, what if I say x? You solve for logs and you get an answer negative 3 and 2, right? But if the base is negative, sure, right? Because that will make sense. But for most times, we're not going to use negative bases for logs. Most of the times, like 99%, we're always going to be positive. So negative 3 and 2, let's say this is true. If I give you the question is log y is equal to log of x, okay? Which of these answers can't work? Can negative 3 work? Can 2 work? Turns out, negative 3 can never be a solution. So our only answer here, x is equal to 2. Even though you came up with negative 3, because I can't plug in a negative to this log, it would never give me a real number. There's no way for me to multiply a bunch of 10s together to end up with a negative 3. Okay, so a couple things that we want to make sure. Whenever you're taking logs of itself, that is equal to 1. Whenever your answer is 1, the log is 0 because that 0 exponent brought you back to 1. And the next one is you can never take a log of a negative number with a positive base, let's say. Okay. So a couple of these things are kind of cool. So you guys will be playing with that. And then the last part is just again on your Excel, just working on some questions. If I say log of 10, log of 100, what type of log is this if, sorry, wrong one, dang it, push the wrong button. What type of log is this if I don't have a base? What's the invisible base? Hopefully you remember. The invisible base is 10. So 10, I'm gonna write this a different color. 10. See, it's invisible 10. So 10 to what power is 10? 10, circle of logs. 10 to what power is 10? 10 to the 1 power. And don't remember, we said they just cancel out because they both have the same base and answer. But 10 to what power? 10 to what power is 100? That's 2. And if you want to double check this, please check this in your calculator. If I write log of 10, you better get 1. You write log of 100, you better get 2 on your calculator. Now here's a weird one. If I say log of 1 over 2 to the 1 over 4. Logs are for exponents. So what's the base? The base is 1/2. So what exponent of 1/2 do we need to get us to 1/4? Let's see if you guys can figure that out. If you guys know the answer, please type in the chat. What exponent of 1/2 would get me to 1/4? How many times do I have to multiply 1/2 by itself to end up with 1/4? Got it. 2. Circle of logs, 1/2 squared is equal to 1 over 4. That's right, our exponent would have to be 2. Good job. That's say you didn't know that. Fine, you didn't know that. Let's type this on a calculator. Log of, I'm gonna help you out. Just write 0.25. That's quarter, right? Divided by log of 0.5, and you'll end up with 2. It's the weirdest thing in the world, right? This looks super weird, and that gives you a nice number 2, because this is just a change of base. And that gives us 2. What exponent of 1/2 would give us 1/4? Well, the exponent is not multiplication, right? It's not what times 1/2. It is how many 1/2s do we need? We need 2. And that's it.